This morning we are going to continue with our limit discussion. So to recap the stuff that we have done, limits day 1, we talked about what a limit was and how to do it from a graph. Limits day 2, we talked about what direct substitution meant, what happens when you get 0 over 0, and we practiced dealing with that with factoring. And I'm actually going to ask that you turn that in here at the end of class. Because this unit's a little bit strung out, I don't want to wait until our first big quiz and ask for a ton of things. So I'm going to ask for just that, but that's from several classes ago, so that one should be finished. Then last time I saw you, we still did 0 over 0, but it was not dealing it with just factoring. We also needed sometimes some conjugates and or some trig identities. And so today we are doing the exact same stuff, except factoring isn't going to be enough on its own. Conjugates are not going to be useful here, and there's not going to be any trig identities with this. So we got to have a different method just because they're a different setup. Okay, but the first few questions here are basically the same, making sure that you remember that you should start off with direct substitution. Hope that you get a real number, and if you do, then that's the end of the question. We're always hoping for that. Also, keep in mind if you do direct substitution and you take a number other than 0 and try to divide it by 0, that's not possible. So we would say 5 divided by 0 is undefined, but we would say that the limit does not exist. And then sometimes we try direct substitution. And we end up with 0 in the numerator, 0 in the denominator, and then 0 over 0 can go to anything. Could be 0, could be does not exist, could be 1, but it really could be anything. It just depends on what the problem is. So, like our last 2 lessons, we've got to think of a way to make this look different without changing the size. And again, notice factoring doesn't seem to make sense here. Trig identities don't seem to make sense. And conjugates don't make sense because we don't have any square roots in here. So the 3 methods that we've talked about dealing with 0 over 0 are just unfortunately not helpful here. So this is what we call a complex fraction. A complex fraction is when you have smaller fractions within a bigger fraction. And so our first step in dealing with this is getting rid of the complex fraction, getting rid of the smaller fractions within the bigger fraction. So what I mean by that is, since this is divided by 3, I would love to multiply this by 3, because times 3 divided by 3 cancels out, and then this smaller denominator goes away. But mathematically, you can't just do that because it's like you're erasing this and pretending like it's not there. If you're going to multiply this term by 3, every term has to be multiplied by 3. So what we're really doing there is we're multiplying the top and the bottom of our big fraction by 3, and we're just distributing the 3 across the numerator. So that's progress because one of the smaller denominators has gone away, but I still have this smaller denominator. So to get rid of divided by x plus 1, I really want to multiply this by x plus 1, but you can't just multiply this by x plus 1 without multiplying every term by x plus 1. And again, understanding what our answer is, understanding the direct substitution at the beginning and end is the calculus part. But for those of you that don't think you're going to go to calculus next year, or anytime in the future. Complex fractions are still a big part of algebra. So I know you don't do much of them, if any of them, in Algebra 2, but even in college algebra, they're going to expect you to use complex fractions sometimes. So this is still good practice for us. Now, one thing I will say about complex fractions is it does get pretty messy here. You multiplied every term by 3x plus 1. Lots of stuff canceled out. So you got to be very careful about what's left over. We've got a 3 times a 1. We've got a negative 1 times an x plus 1. And I'm just going to distribute that. And down here at the bottom, nothing got to cancel out, so we need all of that stuff. 3, x minus 2, x plus 1. So it's not a terribly, like, it doesn't take a lot of learning to kind of figure out what you should multiply everything by, but again, it does get messy. And if your handwriting's anywhere near as bad as mine is, you've got to be cautious of that, because you will miss the question if you're not careful. Now, the reason why this is better is it's no longer a complex fraction. Now we don't have fractions within a fraction, so it's not that it's finished, and nothing from the numerator has canceled out the denominator, so I'm still not ready for direct substitution, but at least the complex fraction part has been dealt with. Now it should be at least kind of similar to some stuff that we've talked about. We could combine the 3 with the minus 1. We know for direct substitution to start working again, something has to cancel out. And this is going to come up a couple times today. There's a little bit of a trick here. This almost looks like this, but it has the exact opposite signs. Negative x positive 2, positive x negative 2. So even though you may not think both of these have a negative, you can still factor out a negative, like a GCF, because that switches both of the signs, and then you have something to cancel out. And we know with direct substitution, the second something cancels out, we should be trying to plug it in to what's left over. Looks like there's just a negative 1 on top and a 3 times x plus 1 on bottom. So if we plug in 2 down here, 3 times 3, all of that goes to negative 1/9. But the main skill we're going to practice on this handout is dealing with that complex fraction. Making those smaller fractions within the bigger fraction go away. Okay, let's look at question 4. Let's do that again. So looking at this one, again, complex fraction. If I plugged in, I get 0 over 0, so I know I have to go through this extra work. But I would love to multiply this by 7, because times 7 divided by 7 cancel. But you can only do that if you're willing to multiply every term by 7. And I would love to multiply this one by x. But if I multiply it by x, everything has to be multiplied by x. So what you're really doing is you're multiplying each term by the least common denominator of the smaller fractions. But you don't really have to think of it quite like that in your head. You can just think about, how do I get rid of this divide 7? Multiply everything by 7. How do I get rid of this divide x? Multiply everything by x. It does get messy, so you got to slow down and make sure you're not losing something. But after these cancel, we were left with an x times 1. After those cancel, we were left with the 7 times 1. In the denominator, we now have a 7 times an x and a 7 plus x. So this first step is just dealing with the complex fraction, getting rid of those smaller fractions. These are saying the same thing. Alright, once we get to that, now this is like the other questions we've done. We know something needs to cancel. This one's a little bit more straightforward than the last example, but x plus 7 and 7 plus x are the same thing. The order that you add things don't matter. And now that something canceled out from the numerator and the denominator, direct substitution should work out just fine. plug in -7 into what you have left over, and since we get a real number, we can assume that is our limit. Now, I'm not going to focus on this too much today, just because I've said it every day thus far, but if you were working a question like this and you happen to have a calculator, which you normally don't in calculus, but you can check by, if you're willing to graph this mess that we started with, look at the x value around -7. Right before it, it should be approaching a y value of almost 0, and right after it should be approaching a y value of almost 0, because -1/49 is very small. So, if you remember how to do limits graphically, you can graph it and then check your limit graphically. Okay, so what about question 5? What is one thing that I should multiply all of these by?
3.
Okay, I agree. Multiplying by 3 to get that to go away. And what else? Okay, and h plus 3, I really want to multiply this one, but to keep it balanced, all of them. This is actually an h. So once these two canceled out, our first term, we're left with a 3 times h plus 2. I'm just going to go ahead and distribute. I think I need to. And once those two canceled out, I was left with a -2 times an h plus 3. And I'm going to go ahead and distribute the -2 as well. And in the bottom, we had an h to start with, but then we multiplied everything by a 3, and we multiplied everything by an h plus 3. That step is really the only unique thing about this question type. You still need something to cancel from the numerator and denominator, and then you still need to finish with direct substitution. It looks like if we combine like terms for this one, all of that just goes to h. So it looks like something is ready to cancel out, which means we can go back to direct substitution. Since nothing's left over in our numerator, that's actually a 1. And we plug 0 back in here, and we're left with 3 times 3, which would be 9. Okay, so go ahead and finish copying that one down, and then I would like you to try number 6 and see how it goes, and at least see how far you get before you get stuck. Unfortunately, these question types are kind of hard to come by, and there's no practice of this type on the other handout today. So we really only got 2 more of these, so I need you to do both of these as guided practice. Do your best with 6 and see if you've got it, or see where you get stuck. Try to learn from that, and then we'll do the same thing with 7, and then hopefully you feel like you at least understand the process. If I remember right from yesterday, this is a little bit longer of a question. But, and I'll give you a few more minutes here, but make sure that you dealt with the complex fraction correctly before you get too deep into the question. I did work out the first step up there. Okay, let me help you get past this if you got stuck. Now, same thing when I did this question yesterday. I'm sure I did this same question last year, but I hadn't thought about it in a while. So I do know that something has to cancel before plugging in 2 gives me my answer. But to be honest, I don't know exactly what's going to happen here. I think it's got another 3 or 4 steps, and it's just too much to ask yourself to expect to know that you're going to do this, then this, then this, then this, and this is going to give your answer. It doesn't always work out that way. Sometimes what you've got to say is, I don't know exactly what I'm supposed to do, but I can try something. So the something that I think you should have started with is maybe take out a GCF out of the top. And then if you tried that, then I may think it's a slightly easier to see the next step, which would be this factors as the difference of 2 squares. And again, I don't know that's what I'm supposed to do. It's just I don't really know what else to try. So I've got to do something. And then it looks like the last piece here before we can go to get our answer is we need the same trick that we saw a couple minutes ago. This term and this factor and this factor are almost the same, but they have exactly the opposite signs. Positive 2, negative x, positive x, negative 2. So you actually need to factor a negative out of one of these, doesn't matter which one. And then once they both have a positive x and a minus 2, they can cancel. And then direct substitution should give us our final answer. Negative 3 times 4 on top, and 4 times 4 on bottom, and that reduces. So make any corrections that you need to there, and then try with the very last complex fraction one we have to look at today, the next one, and try to get a little bit further than maybe you did on this question. But last one to practice, so I want to give you a couple minutes to really give it a real shot. Let's see if you got the right answer, or at least help you see what you should have done if you did get stuck. So I realized I needed to multiply everything by 9, so I did that in red here to cancel out this 9 denominator. And I needed to multiply everything by 3 plus x squared to get rid of this smaller denominator. So once all that stuff canceled, I was left with 1 times 9, and I was left with -1 times 3 plus x squared. And in the denominator, if you want to think of this as over 1, it didn't have anything to cancel out with, so the denominator ended up with all of that stuff. The x that it started with, the 9 that I multiplied everything by, and the 3 plus x squared that I multiplied everything by. Now, I think we saw something similar to this a few days ago, so this is good to see if you fell into this trap. But I know it's tempting to cancel out maybe the 9s and maybe cancel out the 3 plus x squareds, but you can't do that. You can only cancel out factors, which are things that are being multiplied. You cannot cancel out terms, things being added or subtracted. So, I guess like the last question, when I did this one yesterday, I wasn't exactly sure what was going to happen, but I knew I needed something from the numerator to cancel out with something with the denominator. So, I don't know, I went ahead and dealt with this stuff. I thought about 3 plus x times 3 plus x. So I FOILed it out. Again, because I just didn't know what else to do. Then I took a step and it looks like I maybe distributed the minus. And then I can at least say 9 minus 9 goes away. And not only is factoring the most type of way to deal with 0 over 0, it does show up in other question types. So in this one, after you do that and cancel those out, everything in the numerator left over had an x in it. So you could factor out the x, which is good because then finally you have something to cancel out. Again, if you're the type of person that you think you need to know what's going to happen throughout the question before you can feel confident getting started, then these can be a little bit challenging. Most of the times, you just got to do something that you can try, do something else you can try, combine like terms, and then you get closer and closer and you're inching yourself closer to the end, and then hope it gets a little bit easier to see at least. Okay, and then to finish off, plug in 0 for x, and looks like we get -6 on top, 9 on bottom, so -2/3. That's what we were ultimately looking for. So the main thing that you need to get out of these last two examples that you tried before we went over them is just make sure that you highlight or star wherever you got stuck. Maybe you write yourself a little note about what you didn't think about. Like if it's right here, you should write yourself a big note of GCF. If it was up here, you might highlight this squared and write out that you need to FOIL. I don't know. Give yourself some kind of a hint so that if you look back at this, you can remember what strategies you need to use. Okay, so that is complex fractions. Now again, the end of these questions can vary. Some of them were pretty easy. This last one was probably the hardest one. But the main thing that you need to make sure that you get out of today's, the end of these questions is always good practice because that makes it easier. But you do need to make sure that you understand why on these questions we were multiplying by the least common denominator of the smaller denominators. It's to make you go from fractions within a fraction that we call complex fractions to at least we were left with something that wasn't a complex fraction. The question wasn't finished, but it was at least some progress. Okay, And the other thing we're going to look at today, so these questions are quite a bit quicker, but just this is a little bit different. This doesn't have to do with 0 over 0, is doing a limit from a piecewise function. And I can tell you guys in calculus this year, if I had to pinpoint one previous skill that hurts the majority of the students, it is piecewise functions. I don't think piecewise functions are very hard to read. I think that you just don't get enough practice on these in Algebra 2. So a piecewise function has got sometimes y is one thing, sometimes y is something else. Also, piecewise can be in 3 or 4 parts instead of just 2 parts. But it's got a restriction over here. So this one is x squared, or 2 to the x, but only if x is between 0 and 4. If x is bigger than 4, then it's y equals 8x squared, or 8 square root of x. So these tell us when to use each of these. Now if you remember when we went back to limits the very first day and we did them graphically, for this type of limit to exist, it had to be the same as the limit from the left, which had to be the same as the limit from the right. So we actually have to ask ourselves these 2 questions before we can answer this question. You don't have to write this down every time, but you probably should on the first question or 2. If I want to know as x approaches 4 from the left, think about on a graph. If you're coming from the left, you're thinking about an x value that's slightly smaller than 4. So you've got to read these 2 restrictions and realize this is the one that says when x is less than 4. So for this one, we should plug 4 into 2 to the x, and 2 to the 4th would be 2 times 2 times 2 times 2, or 16. And then for the right, on a graph, if you're coming from the right side of 4, then you've actually got a number slightly bigger than 4. So you're welcome to think of that as like 4.01. It's a little bit bigger. And so this one needs to be plugged in to this problem, the bottom function, because it says when x is greater than 4, which is what you would have if you're coming from the right. So when I plug 4 into this, I'm left with 8 times 2, which is 16. And since the limit from the left is equal to the limit from the right, that is the answer to that question. The limit from the left has to be the same from the limit from the right. Now, the trap that some of you guys are about to fall into is you're going to oversimplify this. You're going to just say, oh, okay, so I plug it into the top one, get a number, plug it into the bottom one, get an answer. If they're the same, that's my answer. If they're different, I get a different answer. That's not necessarily the case. You need to actually think about what is the left limit, which one of these should I plug it into, what is the right limit, which one of these should I plug it into, and if it's asking for both, then you need to make sure that you get both. So let me say that again with question 9. So if I want to know the limit as x approaches pi, at least mentally, I know I need to find the limit as x approaches pi from the left and the right. So from the left is when x is slightly smaller than pi. So that would be this guy, when x is less than pi. So you should plug pi into the top equation for this one. And we got to think about our unit circle again. But the cosine at pi is -1. From the right side of pi, that's where pi x is going to be slightly bigger than pi. That should get plugged into the bottom one because it's saying x is greater than pi. And if you plug pi into the bottom part of the equation, the sine of pi is 0. But if the limit from the left doesn't equal the limit from the right, then this one that doesn't have a direction would have to be does not exist. The limit from the left has to be the same as the limit from the right. Okay, let's look at a couple more together and then we'll save, I lied. There's only one more in your notes. So we'll do one more in your notes, one more on the next page, and then have you practice and check to make sure that you don't need anything more specifically. Okay, so the limit as x approaches -2. So I need to figure out what's the limit as x approaches -2 from the left and the right. So the left would be when x is smaller than -2. So that would be the top part. Plug that in, get an answer. -2 from the right would be when x is slightly bigger than -2, which is what the bottom restriction is saying. So you should plug that into the bottom part of the piecewise function. But you get -10 again. And if the limit from the left is equal to the limit from the right, then that is your limit. Not much work to be done on these, but it does 100% rely on you understanding when to use the top, when to use the bottom, when to use both, and the key is reading the restrictions over here. So I want to do one more with you on the last page, plus whatever other questions you guys need to ask. There probably should be one like this on the notes. But question number 1 on the next page wants to know what's the limit as x approaches -5. So I need to think about from the left and the right, and if they're the same, then that's the answer to this question. Well, as x approaches -5, which one of these should I be plugging it into? The top. The bottom, you only use the bottom when x is between 0 and 10, which has nothing to do with -5. So we don't need this one at all for question 1. This is why you can't just say, I'm always going to plug it into both and see what I get. You got to actually think about what you're doing. So from the left, you should be plugging it in here. And that's a little bit harder unit circle question, but it comes out to be 0. But the right is also here. A number just a tiny bit less than -5, and a number slightly bigger than -5. They both go into here. And so if you plug them both into the same thing, you're going to get the same answer. But there are times where you don't need part of your piecewise function. You've got to look at the restriction and not just try to oversimplify it with certain steps. Okay, so I do want you to try again, these do go pretty quickly, but I wanted you to try the rest of these with guess and check. So we're going to do them in a couple different sections, so a couple at a time at first. A couple of these didn't print off great though, so let's go ahead and fix that before I forget. Question 3 only wants to know the limit as x approaches -1 from the left. And I don't think the symbol on that one printed off very well. Make sure you add that in if you can't see it on your page. Question 4 wants to just know the limit as x approaches 3 from the left. Again, I don't think the left part copied very well. And then question 5 wants to know the limit as x approaches -4 from the right. So squeeze a plus there if it didn't copy. Okay, so first off, let's just have you just try maybe 2 of these. So try 2 and 3, see what you get. We'll go over the answers, make sure you're okay with that. Then I'll give you maybe 3 the next time, and then like 5 the last time. But I'll give you a chance to check them all and a chance to check, ask about any of them, just to make sure that this is understood. let's check 2 and 3 and see if you need to ask about those. So 2 wants to know the limit as x approaches -3, so that means we got to check from the left and the right. You should not have used the bottom of this at all. Slightly from the left of -3 and slightly from the right of -3 has nothing to do with values from -2 to 1. This is just there as a distractor. Both of those should have been plugged up here. So slightly less than -3 gives you -6 plus 1. And then if it's slightly bigger than -3, but you plug it into the same thing, well, if you plug the same number into the same thing, you're going to get the same value. So -5. But you need to understand why I didn't use the bottom. Number 3, however, only once from the left. So that would be when your x value is slightly smaller than -1. So once again, we should not be using the bottom because this is when x is bigger than -1. So you plug that in, you get e to the -1, and that's fine if you leave that as an answer. I don't know, if you think of this as a fraction, most of the time in mathematics it's considered unsimplified if you have a negative exponent. So a negative exponent in the numerator is the same thing as moving it to the denominator and making it a positive exponent. Somebody yesterday said that they didn't know what e was, so we will talk about e this semester before it's over. But e is a lot like pi. Pi is about 3.14, doesn't have a repeating decimal, it is irrational. E is also a number, it's about 2.718, I think. Your calculator has an e button. It's not this e above sign. That e is for like writing messages. The lowercase e that's with divide is the number e. E comes up a lot, well, in a lot of real world stuff, but like interest formulas, the PERT formula has the number e in it. When we do logarithms and we talk about natural log is a normal log with a base of e, so e is just a very popular number. So if you didn't see that in Algebra 2, you'll need to make sure you pay close attention to that when we see it a few times this semester. Okay, either of those two you guys would like me to go more in depth on? Question. Okay, then try maybe the next 3, which would be 4, 5, and 6. Okay, so my answer for those three, question 4, I got 8. Question 5, you could write your answer in a few different ways. The best way would be 1/16. But the two other ways before that are also okay, I guess. And then number 6, you had to test both sides and they were not the same, so it does not exist. So again, I'm happy to go over all 3 of those if you need me to. But if you don't, go ahead and try the last little group of them. And if you do, tell me which ones you want me to explain. As you finish those 5, you can compare with mine on the board. But also similar to the complex fraction questions, these are not easy questions to find, so they are kind of difficult ones for us to give you a bunch of practice. So. Alright, any of those you want me to explain where I got my answer from? Okay, it looks like people are still working with it, so I'll give you a little bit more time to make sure. Okay, so another chance. Any of those you got something different on that you want me to explain? Okay. And really the last thing I need from you guys today is, of course, it's a good idea to kind of scan all that stuff again, especially if you thought it was difficult. But to start giving you some grades from this unit, I'm asking for number 65 today. So I did put that in Google Classroom a couple days ago, so if you want to do Google Classroom, that's fine. And if you don't want to scan it and turn it in, you're welcome to just come turn in the hard copy. It doesn't take me but a couple minutes and you can have it back today, but I do need to have that one before you guys leave. It's from several classes ago. Did anybody have any other CAP questions, math-related CAP questions? Okay, I think I got most everybody's work already. But if I don't have yours yet, just make sure I have it from you before you guys leave today. Almost couldn't read that.
Yeah.
You put it on.
Yeah.
Finish it, that's all. It'll give it to me by the end of class. But, or I guess, full credit by the end of class, you can still get half of your points back before the test. Yeah, that was part of last class's assignment, was to finish it. Okay, and you guys still have about 25 minutes, so if you do have anything that you could work on for another class, you're certainly encouraged to do so. There won't be advisory today because of the pep rally, so if you normally do homework during advisory, that's not going to be an option today.